This is the video to accompany my project, Video Game Controllers as Musical Devices. I have designed a system that allows the user to play a drum machine via a PlayStation 4 controller. Following is a layout of where the samples are on the controller. The left and right analog stick are used to loop through samples, allowing the user to scan forward and reverse, and to speed up or slow down the sample. We will now take a more in-depth look at how to run the file and how the system was designed using Supercollider. First, we must open the project CSD file. Next, in order to hear audio, we must boot the server. In order to boot the server, we can either highlight S-boot and press Command and Enter, or we can navigate the server, click Boot Server, or we can press Command and B. I've highlighted S-boot and I press Command and Enter. Next, we must connect the PlayStation 4 controller to Supercollider via HID. To do that, we click on Find Available and press Command and Enter. This lists in green all of the devices connected to the computer. However, this is not convenient to read. So we can go to Post Available Devices, HID.PostAvailable, highlight and click Command and Enter. This lists all of the devices connected to the computer, and we are looking for Gamepad Generic Desktop. When connected via USB, the vendor name will state Sony PlayStation or Sony Corporation. As you can see, vendor name is listed as unknown. Product name is wireless controller, and vendor and product ID are present. However, when the controller is connected via Bluetooth, the vendor name will be listed as unknown. We can connect directly to the controller through its product ID. We use the UGen HID.open and we insert the product ID as an argument into the brackets. We then click and press Command and Enter. This connects the controller directly to Supercollider. All of the drum sounds are samples which are saved in the user home directory and are buffered into memory via the UGen buffer.read. All samples are self-freeing, meaning that at the end of each play they remove themselves from memory. To load these into memory, we highlight the bracket and we press Command and Enter. The samples are now stored in memory and are awaiting commands to be played. In order to use the left and right analog sticks to scan through files, the files are loaded in separately in the exact same way as the previous files. However, they're loaded into an NDEF. An NDEF is a type of synthesizer which has direct access to the outputs from Supercollider. With an NDEF, we can call in separate arguments and do more interesting things than just play the sample. In this case, we're using the UGen playbuff to read in the file. We are using buff rate scale in order to read through the file. There is a separate NDEF for each side of the controller, for the left analog stick and the right. We then create global variables which are assigned control specs from -2 to +2. We then assign the value coming in from analog controller left, which is \x, and analog controller right, which is \z. These values will then be mapped to the arguments rate and rate2, which control the direction and speed of the sample. To map these controls to the arguments, we highlight the bracket above the global variables and we press Command and Enter. Following is a brief demonstration of analog controller left and analog controller right, scanning through samples, playing them forwards and reverse at different speeds. We will now assign the controls from the PS4 controller to play the samples. To do this, we highlight the bracket and we press Command and Enter. We are using the UGen_HID.action, which reads each individual button as an element ID. Each element ID has a number listed here, 0 to 18, and each element is in control of one sample. For example, snare light is controlled by the element 0, and it reads in from the sample snarelight.wav, which is read into the program via buffer.read. The condition of the elements or buttons is monitored by the switch boolean. If the value from the element is 1, the sample will be played. If the value is anything else, the sample will be stopped. Element ID number 18 represents the directional button. The directional button is not binary. It sends out values from 0 to 8. So we use switch combined with the raw value to tell us the present state of the controller. I will now use a controller to play some samples. Kick and snare. Some toms. Cymbals. I'll play a short beat. Tom rolls. Snare roll. To safely free all buffers, close the HID connection and clear the NDEF. We navigate to myhid.close. We click on the bracket before, we press Command and Enter. You can see that all devices have been closed and all buffers have been emptied. Following is a brief performance in a live setting of one of the participants in my survey using the PS4 controller